Hello, beautiful students. Welcome to lesson 2.09. Our competency skill is problem solve, and today I can complete proofs using axioms of equalities. So, there are properties of equalities that we already know how to do, so we're going to activate our prior knowledge by trying out the do now. Now, watch out. Don't forget, when the like terms are on the same side of the equal sign, you combine like terms. When they're on different sides of the equal signs, you always have to do the inverse operations to move something to the other side. So pause this video, try 1, 2, 2, Ms. Cho can't count, 1, 2, and 3, and play the video once you're ready to move on. All right, so you can check your answers right here. X is 20 for number 1, X is 10 for number 2. There's a little segment and addition postulates for the bottom part. So if you got all of these right, you can check it off and move on. If you need a little review, let's go ahead and review. So if our equation like terms are on the same side of the equal sign, then we just combine them. So 2x plus 5x is to the left of the equal sign, so I just combine to 7x. I bring everything down. Then once you get here, there are two terms left, so it's a two-step equation. First, get rid of addition, subtraction. Then I get rid of multiplication and division. So where is there addition and subtraction? Right here. So the opposite of plus 40 is subtracting 40 on both sides. I bring down the 7x, I bring down the equal sign. Then I do the inverse of multiplication or division. A number in front of the variable is multiplication. The inverse is division. So x is equal to 20. Number 2. Here, my like terms are on different sides of the equation. So whenever you go on the other side of the equal sign, you must do the inverse operation. So strategy, I'm going to use the smaller term with the x to keep my numbers positive. I subtract 2x on both sides, get 2x, and I bring everything else down, nice and organized. Then I'm at a two-step equation, so I need to get rid of addition or subtraction and then multiplication or division. So I see addition here, plus 20. The inverse is subtracting 20. I bring down the equal sign. I bring down the 2x. And I divide on both sides to get x equals 10. Number 3, complete the given math statement. So here in our segment and angle addition postulates, it's easy to recognize the whole. So AT is the whole segment. Imagine if you had a chocolate bar. So what is this whole segment made out of? AF and FT. So segment AF plus FT equals AT. Another way to show that is AF using the dash plus FT equals the whole AT. Angles. The whole angle is NRS. It's the biggest pizza slice. What are the smaller angles that make up that larger angle? NRK, NERC, and KERS. NRK and KRS add up to the whole NRS. Pause this video if you need more time. And keep solving equations, and the parts are the whole is the sum of its parts from the do now for today's lesson. So here are some additional properties of equality. So addition property of equality. So if you have, let's say, A and B equal to each other, and you add them to both sides, then the two sides of the equations are still equal. For example, if x equals 5 and you have 2 equals 2, and you add 5 on both sides, you still get 7 equals 7. So in our proofs, you might use addition property, but I like to keep the whole phrase addition property of equality, because you know in your mind that if you add something to both sides, the value will be the same, given that the original amount was the same. Similarly for subtraction property, if you have A equals B and you subtract that amount from a given amount, then you still have the property of equality. Here's another example. If you have 100 on both sides, and we say we subtract 5 on both sides, we still get 95. So if you subtract the same amount, given the constant amount, the property of equality will remain. Reflexive property. It's a shared side in a diagram, but it's basically when something equals itself. Symmetric is, we're not going to really use it, but if you switch the values around, if 10 equals 10 and you switch the number around, 10 still equals 10. Or when you solve equations, you guys get x equals 5, and you guys get weirded out if 5 is on the left side of the equal sign sometimes, but it's still the same value. Transitive property. Now, if you're in 10th grade, you might have learned syllogisms in ELA, and please star transitive and substitution, addition and subtraction, and reflexive. Those are the 5 properties we're going to use today. But back to transitive. If A equals B and B equals C, then A is equal to C. So let's say if x is equal to y and y is 2, then x is also equal to 2. Let's keep practicing. I feel like the more we do it, the more you'll get the hang of it. I just copied and pasted the charts by section so you know which ones to refer to, so you're not flipping back and forth. Key concepts. Axiom of equality. The whole is equal to the sum of its parts. We're going to keep going. Mini number 1, the addition property of equality. If parts are added to equals, then the sum is also, typo, if equal, nah. If If equal parts are added to equals, the sum is also, check my grammar. The sums are equal. All right. So, given step one, we're always going to annotate our diagram. I'm still seeing this step missed, and it's really hard to tackle the proof if you don't have a compass or don't know the givens. So, number one, annotate. CE is congruent to FE, and EB is congruent to ED. Don't forget, these dashes means this whole segment, even though they're in the middle of the segment. Prove that CB is the whole is congruent to FD, this whole segment. So first, make up a test case to make sure you understand what the given is. So let's say CE and FE are the same. So let's just choose a number, 2. So CE and FE are 2. And EB and ED are congruent. And let's say that's 5. Prove that CB, this whole amount, is congruent to FD. So CB equals 2 plus 5, which is CE plus EB. And FD, that whole amount, is 2 plus 5 here, and that is EF and ED. So we could see that the two smaller segments, the parts, equals the whole. The two smaller segments, EF and ED, 2 plus 5 equals the whole, FD. So we're going to apply that to our proof. Fill in the reasons below. We know that CE is equal to FE and EB is congruent to ED because it is a given. CE plus EB equals FE plus ED. So since equals are added to equals, I suggest, how do we get from the first step to the second step? The reason is going to be the transition from the first to second. So we're going to do the addition property. And then from here to here, how do we get CE and EB to CB? We know CE is here, EB is here, and that equals CB, the total. So you could write substitution, or I like to use personally, the whole is the sum of its parts. Because here, this is the whole amount, CB, which is the sum of its parts, CE and EB. Same thing for FD. That's the whole right here. And FE plus ED equals the whole. Ah, the diagram's getting wild. All right. Pause this video if you need more time, and let's move on. Mini. Number 2, the subtraction property of equality. If equals are subtracted from equals, the differences are equal. So let's try to apply this property with angles. given BAD, I saw someone trace the angles and then put the arcs. I like that method. Is equal to measure CAE, which is this arc. Prove that BAC is equal to DAE. Why would this have to be true? Come up with some examples of angle measures to show how this would work. So if we know that angle BAC BAD, I'm gonna use pink, is let's say 30 degrees. And BAD is congruent to CAD, so that's also 30 degrees. Now, we know that they're equal to each other, but what do they have in common? We have CAD in common here. CAD. So we need to figure out what these blue angles are, BAC, DAE. So if I cut out or subtract CAD, I'm gonna have those blue angles left over from the pink. So let's say if CAD is 20 degrees, so I'm gonna subtract 20 on both sides, and then subtraction property of equality, and I'm gonna have 10 degrees left over. And they're also congruent to each other. And does this make sense when we substitute numbers? Yes, because CAD is 20 degrees plus 10 degrees, which is 30 degrees. And BAC is 20 degrees plus 10, which is also 30 degrees. And to get that, we subtracted the reflexive angle, the shared or overlapping angle, 20 degrees from both sides. So let's apply that to the proof. Measure of angle BAD is equal to CAE. That is the given. When in doubt, start with the given. Then, what happened here? What is this craziness math statement? It's all good. M stands for measure of angle. So how do you get from step 1 to step 2? I see that BAD is the whole, and from line 1 we got BAD, and we have BAC, this blue angle, blue angle, and CAD, this middle angle. So we could say substitution, or the whole is the sum of its parts. You could do one or the other, because here's the whole, here are the parts. Here's the whole, here are the parts. Then CAD is congruent to CAD. That's a shared angle, so we know that's reflexive property. Make sure your spelling is correct with the X. And then how do we get from to BAC is equal to BAC? So please start. You always have to establish that something is reflexive. And here, how do you get from 2 to 4? We see that after we established they were reflexive, it was subtracted to get BAC and DAE left over in line 4. So it's going to be the subtraction. I can't spell. Subtraction property of equality. Please write equality, because if you subtract something on both sides that's the same value, then the remaining values will be the same, given that they're equals. All right, pause this video if you need more time, and let's move on. Try out the check for understanding, and your teacher will check before you move on. So the answers will not be on here. Have someone check before you move on to level 2. All right, that's all I have, beautiful humans. Have a great day. Don't forget to refer to the chunked notes or the summary of the notes in the front. Pay attention to the stars. And one more quick thing. Whenever you use addition or subtraction property, something has to be equal to itself, or I recommend including the reflexive before you mention subtraction or addition property equality. But depends on the proof. All right, that's all I have to say. Bye.